Hi guys, welcome back to my channel. So yeah, this video is going to be continuation of the past video where we were discussing the hyperbolic exam questions. So in this one, we're going to be looking into quadratic exam questions. And then yeah, see how we apply the concepts that we have learned. So if you missed our first video on the quadratic concepts, please click the link down below this video so that you can, get up to speed with the concept that we've already discussed. So yeah, let's get to the agenda for this video. So if you allow me, I'm just going to share my whiteboard. Okay, so yeah, the question that I want us to start with is the November 2021 paper, where we were asked some questions on the quadratic function. So let's just ignore that. Okay. Okay. So essentially, this is a continuation of question 4. So previously I looked into the first part, which was hyperbola. So now I'm looking at 4.2 of November 2020. So the question said you were given f of x, right, which is a parabola, and it's given in the form of what? It's given in the form of y equals to a x plus p squared plus q, right? Remember the important concept that we've discussed about what p means, what q means, right? When you are given quadratic in that form. So just to remind you, we said q is the y value of the turning point, and then x equals to minus p is the x value of the turning point. So meaning the coordinates for a turning point, if you're given the quadratic in that form, is minus p and q, right? And then we did mention that it tells us the shape of the graph, whether the graph is going to be smiling or it's going to be sad. So if a is positive, our graph is smiling. In other words, it has a minimum. And then if a is negative, our graph has a maximum. So yeah, looking into our graph here, you can see that a is positive. So that's why our graph is smiling. So that's just a good check. Okay, and then they told you that you're also given a g of x. G of x is a linear function, right? So we know that linear function is the functions of the form a x plus p, right? Or mx. I don't know what in your notes you've been taught. So yeah, m is the gradient, and then b is the y-intercept, right? Okay, yeah, it's just important to think about this concept before you even start answering the question, because it helps you to be able to answer the questions much quicker. Okay, so let's go down. So they say a is the turning point. So remember, we already know the coordinates of the turning point because of like this concept that I just said here, right? So in this case, the turning point's coordinate is -5 and -8, right? So I don't know what the question is going to ask, but if they ask us coordinates for turning point, they already have the answer straight away. Oh, there we go. So that's just straightforward. You see, they say write down. They don't say determine or calculate, because they know that it's a straightforward answer if you understand the concept. So we can straight away jump into answering that question. So we know that the coordinate is going to be -5 and -8. Boom, 2 marks. Okay, so they say write down the range of f. Remember, what's the range? The range is a set of all y values that your graph can take, right? So remember, for quadratic functions, the range is always y is element of, y is element of all the numbers, yes, but y is sort of restricted by what? Either the maximum, right? So either the maximum or the minimum. So if your graph has a minimum, then which means your graph is going to take all the positive I mean, all the y values starting from the minimum going upward, right? And then if your graph has a maximum, then your range is going to be all the y values from negative infinity up to the maximum. So in this case, we have what? We have minimum. So the range is going to be y is element of all real numbers. So you can just say, so yeah, actually, let's just write it in terms of the brackets. Remember, the square bracket means including, right? So you can just say from, okay, it's -8, right? Up to positive infinity. Or another way of writing it, you can just say y should be greater or equals to -8. So in other words, it's going to be, okay, let me write this neatly, guys. So you can write this as like y is element of all real numbers, right? And y should be greater or equals to, what am I doing? Okay, -8, essentially. So yeah, you're just saying like, your graphs can take all the y values, and those y values, they must be at least -8, right? Okay, that's your range, that's easy one mark. So I prefer this notation. Okay, so then the second part is they calculate the values of m and n. What is m and n? So m and n is the point D, right? Is the coordinates of point D, and D is sitting on what? Is sitting on the line g of x, right? And more interestingly, we can see that coordinate of x of g at the point D is on the same line as what? It's on the same line as x-intercept. I mean, x turning point of the graph f. So which means if we know the x coordinate of the turning point of f, then we also know the x value of coordinate d, right? So in other words, dx equals to -5, right? Equals to -5. Why? Because which is equals to m, obviously. This is because they are on the same line. So we already know what's x for a. So then, which means that x is the same x as what? It's the same x as the value of m. So we already know x value. So if we know x value, to get the associated y value, which is like the n there, the n. So we have to substitute that x value into our equation, right? Because we know the x value of that. So which means then we can say that so we know that m equals to -5, therefore n equals to a g of -5, right? And then if we look into our equation, so what is g of x? 1/2 plus 9/2, right? So then we know that that's going to be 1/2. Then we substitute -5 plus 9/2, right? So if you solve for this, then you're going to have -5/2 plus 9/2, right? So this gives us 4/2. So which is equals to 2. Okay, so then we know that, okay, the coordinate m is given by -5 and 2. And then you can just check this answer for reasonability just to see if it makes sense. So if you look into our equation, so you can see that yes, n has to be positive, which is 2 there, and then m is a -5, right? So we have answer for we've answered those questions, right? Those questions. So the coordinate is, the value is -5 for m, and then n equals to 2. Okay, and then the fourth question, they ask you calculate the area of OCDE. Okay, I'm just going to open my whiteboard and then we discuss. So they say determine the area for So you're given this form, this shape. They say determine the area for this guy, right? This guy, for this guy, for this guy. Let's go back. Okay, so okay, okay, so okay, so this is E, right? This is E, O, C, D, right? And then, so they want us to get the area for this, right? So there are two ways of getting the area. The other one is more efficient. The other way, okay, firstly, we need to understand what shape is formed by this. So one can either draw a line here, right? And split this thing into two parts. Remember, this line is, my diagram is not drawn perfectly to scale, but this line is parallel to x-axis, right? So remember, this is, y-axis, this is y-axis. Okay, so these lines are parallel and yeah. Okay, and then this is also, this is x-axis, this is x-axis. So they want you to find the area of this whole thing. So one way is, one can say, split this thing into triangle and rectangle, and then find the area by using the area of this area of, yeah, let's say area of area. So I'm just going to decide area, right? So one way of doing this can say area equals to area of A plus area of B, right? So obviously the area of A is area of a triangle, and then the area of that's area of a rectangle. So then if you go down on these, so you're going to have 1/2 a base times height, right? Plus length times breadth, for area of rectangle. So your length is going to be OE. So if you know the length of OE, then you substitute that, and then if you know the height there, which is O, let's suppose this is C star. Okay, so C star. Okay, so then you substitute that there, right? Yeah. Alternatively, okay, so for triangle here, so obviously you have base, which is D, C star, and then the height is this guy here, right? This guy here. So yeah, another way of doing this, which is I think more efficient, is to use the area of trapezium, because this is a trapezium shape. This is trapezium, and we know that area of a trapezium. So we know that the area equals to 1/2 A plus B times height, right? So where you have A being something like this, right? So in this case you have a situation that's more like this. Okay, so this is one form of trapezium, and then so in this case A will be this side, and then this is B, and then this will be your height. So in our case, our trapezium, it looks like this. So if I write this, it looks like this. Okay, so it looks like that. So where this is A, right? Then this is B, and then this is your height. So this is vertical, right? So essentially, I just turn the shape just slightly, right? So this is A, and then this is like B. So essentially, taking these two sides, right? These two sides, and this is, you take this as height. Okay. So now let's go back. So essentially, we need to know what is the length of OE, because those are important length. So we need to know what is OE, because it's important. And then we need to know what's the length of what? DE, right? And then we need to know what's the length of what? the length of, remember DE is the same length as OC because they are on the same horizontal line, right? And then we need to know the length of OC, right? So, because if we know DE, which is B, the smaller side, and then we have OC, which is A as this side, and then now the height is OE. So if you know those three sides, then you can answer this question. So let's go back to our diagram and see if we can derive those. Yeah, so if you look into our diagram here, so you see OE, so we know this length. Why? Because remember, this is just straight length from, okay, the X here we know is -5. So -5 to 0. So this distance is what? Is 5 units, right? It's 5 units. It's 5 units. So it's 5 units. And then the length of OC, so from O to C. So remember, this is from 0. What is C? C is a y-intercept of G. So that length, that point there is 9/2. So which means this length is 9/2 as well, right? Because it's 0 to 9/2. Okay, so it's 9/2. Okay, this length, OC. Okay, and then, okay, now we don't need to know DE. What's the length of DE? So remember, we know that this point here is 0, and then what's, yeah, so this is N. So this length here is equals to, like the N is equals to the value of N. Remember, N, we determine N to be 2, right? In our, yeah, in our formula here, right? We determine N to be 2, essentially. Because, yeah, you study from 0 to 2. Like that's the length of this. It's 2 units. And then this is 5 units. This is 9/2 units, which is like 4.5. So yeah, we know those 4 lengths. And then we can just substitute straight into our formula. So we can substitute straight into our formula. So DE we know is equals to N, which is 2, right? Which is B. Remember, this is the same. It's the same as B here. Okay. And then our A is the same as OC, right? OC. And then OC is 9/2, which is 4.5. And then what is this guy? This was the H, right? Which is equals to 5 units. Because yeah, from there to there, it's just like 5 units. So essentially, yeah, the diagram that I have here, right? It's just tilting this guy, just, 90 degrees to the left, just like boom, once. Okay, so that you can have a clear shape of a trapezium. Then yeah, if you substitute these into this function, then you're just gonna have, also if you look into this, actually you can simplify this into this formula, essentially, because if you take B as a common factor, then you're gonna have B as like your height, right? Remember, as a height, as this height. And then yeah, you can, like you'll see that essentially to get to this formula, they derive it from here. So I think this is a long way of getting the answer. If you want to split this into 2 parts, the straightforward way of getting the answer is this way. Okay, so if you substitute those values there, then you're gonna have 1/2. What is A? A is 2, right? And then what is B? B is sorry, A is 4.5, but like it doesn't matter because you're adding A and B anyways. And then like 4.5. And then what's the height? 5, right? So yeah, if you try to simplify these, so you can think of it, okay, this you have like 6.5. 6.5 is the same as 13/2. So 13/2. So it's like 1/2 times 13/2 times 5, right? So yeah, if you multiply this out, you're gonna have 13 times 5 divided by 4, right? 13 times 5 divided by 4, so that's 26 plus 39. Yeah, so 26 plus 39. Yeah, that's the same as like okay, 65. I think 65 over 4. Yeah, 65 over 4. Okay, that's like the area. So, but remember, you need to write your area in terms of what? Unit squared, unit squared, unit squared. So that would be the area of that region there. Okay. Yeah, I think that brings the end to our first quadratic question. Okay, no, there was another part here. Okay, there were 2 parts left. Okay, so yeah, so the 5th question was saying determine the equation of g to the power of negative. Remember, g to the power of is an inverse function. So how do we get the inverse function from our function? So essentially, to get the inverse function, all you have to do is you substitute x by y, right? So it's like you're swapping x and y, and then you write your new function in terms of y, if that makes sense, essentially. That's why they say like in the form of y. So essentially what happened is like where you see x, you substitute by y, and then you rewrite the equation in the form of what? In the form of y. Okay, so let's write down our equation for g first before we get the inverse of it. So equation for g of x is given by 1 over 2x plus 9 over 2, right? Okay, so then they say we should get inverse, right? So inverse g inverse. So this implies that sub y for x, right? And then you rewrite. So essentially that's what it means. You sub y, when you see x, you substitute y, and then you rewrite the equation. Okay, so remember the g of x, this is the same as y equals to this. So what you're gonna do is you're gonna replace our y by x, and then you're gonna have 1 over 2. Okay, so what is gonna be x there? Where is x? You substitute y, right? And then you have 9 over 2. Okay, so then yeah, now we just need to rewrite this equation in terms of y. Then that will be the inverse function that they're looking for. Okay, so to get that, so what we need to do is we can multiply both sides by 2. Then you're gonna get 2x, right? So if you multiply this by 2, you're gonna get the y, obviously, plus 9. Therefore, this implies that y equals to 2x minus 9. That's your new equation. That's your new equation. That's the inverse function that they're looking for. Okay, that's the inverse function. Yeah, the principle is that when you get in the inverse function, you just replace x value by y, and then you write your new equation in the form of y. And then, or like in the form that y is a subject of the formula, and then that will be a inverse function. Okay. So yeah, then let's look into this follow-up question. So the follow-up question was saying that, yeah, okay, they were saying like if h of x, which is inverse of a g plus some k units that we don't know. What's the k units? We don't know. They say it's a tangent to f. Determine the coordinates of the point of contact between h and f. Okay, so let's just scroll upwards so that we make sure we understand the question. So they say like you have this function of f, right? So then they say the inverse of g, which is the reflection of g in the line y equals to x, is having a tangent, right? So I mean it's touching the graph. Sorry, it's touching the graph of f at some point. F, right? And then we need to determine the coordinates of that point where they touch each other. Okay, so this important principle that we need to understand. So this, it's a combination of calculus and this and the functions, right? So we need to, yeah, we need to remember those concepts because they're gonna be handy here. So essentially, if you have a graph of like yeah, let's just say you have a parabola there. So a tangent is it's a line that just touches the graph. You see, it touches the graph at some point. Like it doesn't cut through the graph. It only touches the graph at one point. Okay. So the important principle is this. At this point, right? At this point, two things are happening. One is that at the gradient of this line at this point, it has the same gradient as what? As the function at this value of x. So this will become very clear when you get to calculus section. So the key is that at this value of x, right? At this value of x here, at this value of x here, for this value of x at this point, this line, let's just say h of x. This line here has the same gradient as f of x at this point. And at the same time, they share the same point, right? They share the same point. So essentially a tangent, let's say a tangent and a function, tangent and function, right? So at the point where they meet, right? At the point where they meet, they share gradient, and then they share a point, right? So this is a very important concept because like you're gonna find a lot of questions in exam where they ask you this. So which means then if we can get the gradient, if we can get the gradient of either the line or the gradient of f of x at this point, then we know the gradient of either of the two, right? And then once we have the gradient, and we know the value of x here that give that gradient, then we can substitute either, we can substitute that x value either in one of the two equations. If we know one of the equations, we can take that x value there that gives to that gradient, and then we solve for what? You solve for y, then you get the coordinate of the point where they intersect. Okay, let me try to repeat this because it's very important. So one is that, so at the point where the function and the gradient, the tangent they meet, so the gradient of that function and that tangent is the same. Remember the gradient for tangent, because it's a straight line, is always gonna be same everywhere. But then for the curve, it differs depending on where the origin of the curve you are at, right? So, but at this point, they have exactly the same gradient. So if we know the gradient at that point, and then we know the x value at that point, then you can substitute that x value into one of the two equations if we know it fully, and then you get the y value. And then that will give us the coordinates at that point in time. Okay, so in our case, so we had the graph of h of x, which is equals to g of x plus k, right? Remember we determined the graph of g, inverse of g, which was -2, it was 2x minus 9, right? So which means then we have a h of x equals to 2x minus 9 plus k, right? K is, we don't know k. So which means we don't know fully the function of what? We don't know fully the function of h of x. Okay, but then we do know fully the function of what? F of x, right? So so I just wanna pause a bit to switch on the line. Okay. Yeah, so we do know the coordinate for, we do know the coordinate for the function of f of x, right? So we do know the coordinates for f of x. So let's look at the function of f of x. We are given that function. So the coordinate for f of x was given by, okay, see 1 over x, okay, yeah, okay. So we are given, we know the function of f of x. So f of x, we're given f of x equals to 1 over 2 x plus 5 squared minus 8. Okay, so from calculus, we can derive the function of the gradient of a function, from the first principle, so if you take the derivative of this function, if we take the derivative of f of x, right, that's going to give us the function of the gradient at any point in time. So which means once you have this function, derivative of f of x, if we plug in the value of x at any point, that's going to tell us what's the gradient of the curve at that point in time, right? So for us to get the gradient, so I suggest that, the first step that you do, perhaps to make things simpler for you. So let's rather, expand this function into a standard form, right? So if we expand this to a standard form, you're going to have 1 over 2 x squared. So essentially we're just splitting it, right? So it's going to be x squared. So it's going to be 5x plus 5x, that's going to be 10x, right? Okay, and then you're going to have 25, okay, minus 8. Okay, so essentially I just not factorized, I sort of broke the factorization in that term, or expanded it. So then I can now add or multiply throughout by 1 over 2. I'm trying to write this thing in a standard form so that it's going to be easier for you to differentiate this function or to find the derivative, right? So if you multiply throughout by 1 over 2, you can have 1 over 2 x squared plus 5x. Okay, so that's going to be 25 over 2. 25 over 2 is the same as 25 over 2. So that's the same as 12.5. 12.5 minus 8. So that's like 4.5. So that's the same as plus 9 over 2. Okay. So now you have your f of x, which is written as same as 1 over 2 x squared plus 5x plus 9 over 2, right? So now what I want us to do now is to find the derivative of this. I want us to get the derivative of this. Remember, the derivative rule says that if you have ax b, so then the derivative of this is going to be a times b x b minus 1, right? So essentially, and the derivative of constant is 0. So if we do that, so we're going to get 1 over 2 times 2x 2 minus 1 plus 5, right? 5 is going to be x 1 minus 1, which is going to be 0. Okay, so then derivative of constant is 0. Then your derivative now is going to be x plus 5. Okay, that's the derivative function of what? F of x. So this is f of. Okay, so now that you have f of x, derivative of f of x, then which means that for any value of x on the curve f of x, if we substitute that value into this function, it's going to give us the derivative. Okay, but what do we know? We know at this point that the derivative of the tangent and the curve is the same, right? And we know the derivative of the tangent because remember the tangent, the gradient is 2. Okay, even though we don't know the intercept, but we know the gradient is 2. So that means then that if we let f of x equals to 2, then that is going to tell us the value of x here. that make us the gradient to be 2 in the function of fx. Then if you get that x coordinate, then you're going to take that x coordinate, substitute it back to f of x to get the y coordinate. Okay, so here what you're going to do is, okay, so we're going to say x, I'm just going to use different pen here, x plus 2, okay, no, sorry, x plus 5 must equals to 2, right? Because this is the gradient of what? This is equals to the gradient that we're trying to solve for. Remember, the gradient has to be 2 because the tangent and the function at that point, you know, they have the same gradient. So that means then x equals to minus 3, because you're going to take 5 to the other side. So at x equals to minus 3, then the gradient, so at x equals to minus 3, the tangent and the curve, that's where they touch each other. And then the gradient at that point is what? Is 2. But then we don't know y value. How do we get y value? Because of x value here is common between f of x and h of x, then either we can substitute that x equals to minus 3 into h of x to get y value, or f of, but for h of x, we don't know k, so we're not going to be able to know the y value. But here, we do know this. We know all the function parameters. So if you substitute x for minus 3, then you can solve what? You can solve for y value. So then that's going to be, so if we have f of minus 3, which is going to be 1 over 2 minus 3 plus 5 squared minus 8, right? So this is going to be 1 over 2, and then this is 2 squared minus 8. So this is the same as what? It's the same as 1 over 2 times 4 minus 8, right? So that's the same as 2 minus 8, which is equals to minus 6. Okay, therefore, that means then the coordinate at which the tangent of h of x, the tangent h of x, this is the tangent, right? Tangent meets f of x, right? Those coordinates are minus 3 and minus 6. Okay, so yeah, and you can test this out. You can test this out by substituting this x value, let's say, into a derivative function to see if you get 2. And also, if you try to draw a graph of h of x, you will see that it meets f of x at this point. Okay. Yeah. This concludes the lesson. Not the lesson. The question for 2021. I don't think there's any question left on this section for us to cover. Yeah. So this is the end of November 2020. So now let's look at November 2021, the exam question, where they ask about quadratic. Okay. So yeah, so here they will say you are given a graph of f of x is drawn below. Remember, look at the form that they gave it. Remember in my video, we discussed 3 forms in which the function can be. Either you can get it in standard form, right? Ax squared plus bx plus c, or you can get it as ax plus, ax plus p squared plus q, which is what we just saw in November 2020. Or we can get it as what? Y equals to ax plus, okay, not x plus, let's just cancel this. And I do it. Okay. So get it as x minus 1, x minus x2. Okay. So this is the form that we currently have, right? This is the form we currently a, it means it's equals to 1. And then already from there, we can determine the intercept, because remember x1 and x2 are the what? X-intercepts, right? So in this case, it means our x-intercept should be minus x1 and 0 and minus x2 and 0. Okay, not minus x1 and x1 and this is our coordinates, right? So this is our coordinates. Our coordinate is x1 equals to 0 and x2 equals to 0. I mean x2 and 0 and x1 and 0. So, but obviously be careful because, like, you know, our notation here is in the form of x minus x1. It's not x plus. So which means if you have x plus, then that means x1 equals to minus 4, right? And then if x equals to minus, then that is exactly the same form, then that x equals to 6. Okay. Yeah, I'm just, you know, getting you to think about these things. I'm not saying that this is what they're asking, but I'm just trying to get you to think about these different forms at which quadratic function can be given, and also for you to think about how you can answer the questions when they ask you, right? Don't get confused. Okay, so if you look at this, they say parabola cuts the x-axis at point B and then in D, and the y-axis at G, right? So those are just y-intercept, right? So this is x-intercept at B and D, and then the cuts, okay? We see that. Okay, so then they say, and then C is the turning point. C is the turning point, we see that, C is the turning point, great. Okay, so then they say the line AE, like, you know, we see that line there says has an inclination of what, theta, and cuts x-axis and at what, at A and B. Okay, then they say T is the point of F, is the point on F between B and G. Let's look at T. Oh, there we go, we see T man there. Okay. Okay, so then the first question is write down the coordinates of what? Write down the coordinates of B and D. Remember, when the questions say write down, they don't need you to do any calculation. You just have to get the answer straight, either from your previous questions or from the information that they gave you. Since I've already mentioned to you that, you know, when the equation is in this form, the x coordinates are x1 equals to 0, x1 and 0, and x2 and 0. So let's look in our form. So in this case, what is our x1? x1 equals to minus 4 in this case. x1 equals to minus 4, right? For you to look in that form, right? Because it's going to be x minus 4, right? You see, and then x minus 6. So which means x1 is minus 4, and then x2 is 6. Okay, so then the coordinate is going to be x1 equals to minus 4, and then x2 equals to 6. Then you can write those coordinates down straight away. So which means our coordinate, they will be the coordinate will be minus 4 and 0 and 6 and 0. And then if you look at our graph, you can simply check if this makes sense. You can see that our graph is more to the right, right? So which means that we expect this guy to be slightly higher than what this guy, because the graph is more to the right. So 6 and minus 4, they make sense. So then that's the answer for B and D. Okay. Okay, then say write down the coordinates for C. Okay, calculate. In this case, they say calculate. So which means you might need to do some form of calculation. So what is C? Remember, C is the turning point of our graph, right? The turning point of our graph. So in the previous video, I didn't mention one of the important, or another formula for us to get x-intercept, I mean, x value of the turning point. Remember, we did touch that, you know, if you're given parabola in a standard form, the x turning point, okay. Yeah, we touched that the x turning point, it can be found by taking minus 2 over 2a. So I don't want you to go on to expand this and then to write it in a standard form and apply this formula, right? So another way of getting the x value of the turning point. Remember, x value of the turning point, this line is a symmetrical line, right? So in other words, when they say symmetrical line, it means to split this graph into two parts. So this guy here, essentially, this guy is the midpoint. So the x value here is the midpoint of what? Is the midpoint of the x-intercept. In other words, so you can use the midpoint formula to get what? To get this guy, to get the x value there. Essentially, what's the midpoint there? So you have to get the midpoint, then you have to take this guy here and this guy, right? So to get the midpoint. So this is another way of getting what the x value of the turning point when you're given both x intercepts without having to expand it and apply this guy. So okay, so which means we can say x turning point, let's say xtp equals to what's the midpoint? We already know this guy, x value here is what, 6, right? So we say equals to 6. And then this guy, the value is -4. Okay, so if you divide by 2, then that gives you a 2/2, which is equals to 1. So which means this guy, then the x value here is equals to 1. Okay, so that's the quickest way of getting x value of turning point when you are given the x intercepts. Otherwise, which is the long way, I don't recommend that. So if you can expand this formula, right? You can expand this, and then you can write it in a standard form, right? In a squared plus bx plus c, and then from there you apply this formula. You're still going to get the same answer, but this is the quicker way when you are given the x intercept. Okay, so then once we know the x value, right? So which means we need to substitute f of 1, right? F of 1. So if you substitute f of 1 into the equation, then it's going to give us the y value corresponding to what? Corresponding to this x. So in our equation, we have 1 plus 4, and then 1 minus 6, right? We're just substituting 1 into our f of x, right? So that gives you 1 plus 4, that's 5, and then this gives you minus 5. Then this is like 5 times minus 5, that's minus 25. Okay. Okay, then that means the coordinate for C, then that's gonna be 1 and minus 25. Simple as that. Okay, and then they say determine the range of f. So the range of f, remember the range we said is the set of all y values that the graph can take. So our graph has a minimum, so which means our graph can only take the y values starting from minimum going upwards, right? So the range then in this case, one way of writing it is to say, another way, let's just go a little bit down. I'm trying to create a room. So the range is gonna be, equals to y is element of all real numbers. Okay, but y should be greater or equals to minus 25, right? Or alternatively, you can write it as all values from minus 25 up to positive infinity. That's another way of writing it in an interval notation, right? Yeah, that's the range. That's why they just say write down is 1 mark. Okay, so then the follow-up question says you're given that theta equals to 14.04, and the tangent f at t, right? The tangent to f at t is perpendicular to AE. Calculate the gradient of AE, correct 2 decimal places. Okay, so we're given 2 things here. So firstly, we're given this angle theta. Remember, this angle theta forms from x-axis to the line AE, right? And you're also given that there's a line that is tangent to the graph of f, right? And that line of tangent touches the graph at point T, right? Touches the graph at point T, because they say the tangent to f at T is perpendicular to AE. Okay, so let's try to draw a scenario so that you can visualize this, what's happening. So yeah, they're saying that you have, remember, you have this situation here. So firstly, you have this guy. Okay. So this is theta. Okay. So this is line AE, right? This is A, this is E. Okay. Then you had the parabola there. So let's just say X, this is Y, X-axis. And then the Y-axis. Okay. So yeah, so you are given that when I think you're given, let's go back. So you were given that function there. Okay, cool. So yeah, so then yeah, you had some function here that they had some function, yeah, so they just had some function there, that's fine. And then you had some point t here, right? So they told you that this is some tangent that you don't know. There's some tangent that you don't know that is touching this graph, right? So somehow it's perpendicular to, yeah, so let's assume it's, yes, tangent touches this graph here, right? And it's perpendicular, so it forms 90 degrees with line AE, right? So this is point T. Okay, so yeah, this is your tangent, right? It's perpendicular to line AE and it touches the point T here, right? So this is f of x. And then they give you this angle, they say this 14.04, right? 14.04 degrees. So the first question asks you to determine the gradient of AE. The gradient of AE. The gradient of AE. Let's look into that. The gradient of AE. Okay. So this requires to remember some concepts that you've learned in analytical geometry. That if you're given a line, like this, so you can find this gradient. By saying tan of theta, that is the same as the gradient of this line. Okay. So if you want to see the proof of how this is derived, so this is essentially coming from those things that you've learned, remember? So if you have x here, so this is origin, right? So if this is origin, so if this coordinate is x and y, remember y is the opposite side, right? Y is opposite side, and then x is adjacent. So remember from the ratio, trig ratio, tan of theta equals to opposite over adjacent. So opposite is gonna be a y over x, right? So, but then this y over x, if you say x minus 0, x minus y, yeah, y minus 0, x minus 0, this is the same as saying the gradient of this line, because the formula for gradient is y1 minus y2 over x2 minus, okay, x1 minus x2, right? So in this case, like, you're using 0 and 0 as like, one set of coordinates and that. So that's how that is derived, right? So in this case, the gradient for AE, so the gradient for AE equals to tan of 14.04. Okay. And then they said like we should get the answer to how many decimal places. So let's check what they said. How many decimal places? Okay, so my calculator. Yeah, they said to 2 decimal places. So if you look into that, I think there's a one decimal place. Yeah, to 2 decimal place. Okay. So yeah, that gradient is gonna be tan of 14.04. Yeah, the gradient is 0.25. Okay, and then now interestingly, they said that the gradient of, okay, they said like the tangent line that passes at point T is perpendicular to AE. So, and then we know that if the lines are perpendicular, it means the product of their gradient is -1, right? So which means the gradient of the tangent, is gonna be, let's say, m tangent times 0.25 must give us -1, right? Because that's the principle when the lines are perpendicular, right? So that means then that that means that the MT, the gradient of MT is the same as what? Is the same as -1 over 0.25, right? So that is the same as -4. Okay. So gradient of the tangent to the f of x, that's minus, it has a gradient of -4. Okay, let's go back to the question. I just did this so that, you know, we can just think about the ideas before we look into the question. So we've already answered this one. So this is 0.25, right? This we've covered. Then the second, calculate the coordinates of point T. The coordinates of point T, remember what we said in the previous question. We said that when a tangent and the graph, at the point where tangent and the graph, they meet. So the gradient for those two are the same, 1, right? And then 2 is that they share the same point at that point. And then which means if we know the equation for one of the two, either the tangent or the function, then you can substitute that x value at that point that, you know, makes the gradient the same into the one of the functions to get the y value that correspond to that x value. Okay, so, and then we also need to remember some few techniques from calculus of differentiating what a function. Okay, so in this case, f of x is given as x plus 4, x minus 6. So we need to get the gradient of what? We need to get the gradient of f of x, because that's going to help us to get the x value at which you know, the tangent meets f of x, right? So we have f of x that is given as x plus 4 and x minus 6. Okay, so we need to write this in a standard form so that you can differentiate it. So this is going to be x squared minus 6x plus 4x, that give us minus 2x, and then this give us minus 24, right? Okay, so now can we find the derivative of f of x? The derivative of f of x. So derivative is going to be 2 x 2 minus 1, you know, then it's going to be minus 2x 1 minus 1. Okay, so remember the derivative of constant is 0. So then this is going to be 2x minus 2. Okay, so then what do we know? We know that, okay, this is a function of derivative of f of x at any point. But then we know at this particular point where the tangent and the graph meets, the gradient has to be what? Has to be the same between tangent and the graph. And we already know the gradient for the tangent, right? Because it's minus 4. Okay, so which means then if we equate this function to the gradient of the tangent, then it's going to give us the x value. And once we have the x value, you can substitute x value into f of x to get what? The y value. So that means then the gradient for tangent equals to minus 4, which equals to f of minus x, right? So we need to equate to this. Okay, let's say let, because this is important. Then 2x minus 2. Okay, let's solve for x. So x is gonna be then if we take this, so this is gonna be minus 4. Minus 4 equals to 2x minus 2. Okay, so we take 2 to the other side, then you're gonna have we're gonna have minus 4 plus 2, that gives you minus 2, right? So that implies that you're gonna have, okay, I'm just gonna take it here, right, so that we can solve it. So you're gonna have minus 2x equals to 2. Therefore, this implies that x equals to negative 1. Okay, so which means at the point where x equals to negative 1, so that's the point, at the point where x equals to negative, that's the point where the gradient of f of x equals to a minus 4. Okay, so now we need to get the y value that corresponds to that x equals to minus 1. So if we get f of minus 1, that will give us the answer that we're looking for. So then you substitute x for minus 1, then you're going to get a minus 1 plus 4, and then 1 minus 6, right? So that's going to give us 5, no, not 5, sorry. So that's going to be plus 3. That's going to be plus 3 times minus 5, right? That's minus 15. Okay, so which means then the coordinate at which this they meet is gonna be, the coordinate is gonna be -1 and -15. That's the coordinate at which these two functions they meet, the tangent and the tangent and the function. Okay. Yeah, so now let's look into the last question. So the last question, yeah, so the last question was saying that, yeah, a straight line G parallel to AE. A straight line G, which is parallel to AE, cuts F at what? At the point K equals to -3 and 9 and R, right? So calculate the X coordinates of R. Okay, let's try to draw a diagram again so that we can visualize what's happening. So I'm just going to pause a bit. Just want to check something quick, please. Okay, yeah, sorry. I just had to sort out something quick. Okay, sorry, I just needed to sort out something quick. Okay, so let's go back to the question. So we're given that, so remember you had your function of f of x, right? So, okay, so, and then you had the line AE, somewhere there, right? I'm not drawing this perfectly as it was before. I'm just trying to make a point here, x and then have y. So yeah, there's told you that there's another line, right? There's another line that is parallel to this line. So let's assume this is the line that they're talking about. So that line cuts the f of x at what? At the 2 points. One point is -3 and -9. The other one is point R. We don't know that R. Okay. So they want us to get the coordinates of this R. Okay, first of all, they told us this line is parallel to line AE. What does it mean for the lines to be parallel? So if you remember from the analytical geometry, if the two lines are parallel, it means that their gradient is the same. Okay, do we know the gradient of this line? Yes, we do, because we used it from that angle they gave us is 2.5. 0.25. So then that means then for this line here, we can find the coordinates of it, right? So this line, the coordinate is gonna be, so if we have y equals to mx plus c, okay? So we already know the gradient is 0.25 x plus c from what? From the property of the parallel lines, right? They have the same gradient. Okay, so then we also know one of the points, which is -3 and -9. So which means if we substitute this point into this equation, we can get the equation of what? Equation of this line here, right? So which means then if we substitute there, we're gonna get -9 equals to 0.25. What is x? X is -3. Let's see. So if we take this to the other side, then we're gonna have -9 plus the root terms, that's going to be 0.75 equals to c. Okay, so then that's going to give us the answer of -8.25. -8.25 equals to the value of c. Okay, so okay, so that means then like the equation of this line that we're looking for is given by y equals to y equals to 0.25 x minus 8.25. Okay. So then now for us to get the coordinate of R, remember the principle is this. So when you have, when you are at the points where the two curves, they meet each other, like, those curves or those functions, they share the same coordinates, right? So if you equate the two functions together, then that means so what I'm saying is like the y values at the point which the functions meet each other, they're the same. So the y value and x value, everything is the same. So here, a function of f of x is the same as what let's assume this is h of x. So yeah, at this point, they share the same x value and y value. At this point, they share the same x value and y value. So because of at that point, they share the same coordinates. If we equate the two functions, then it's going to allow us to solve for it. It's going to allow us to solve for those coordinates at which they're equal. And once we solve for those coordinates, then that will have been answering the question. Okay, so that means we need to let h of x, right, equals to f of x. For us to solve what? For us to solve these values here, right? The values at which we already know one of them. We just need to know this one here to get the point R, right? So we're gonna get two solutions, the one for here and the one for here. So by letting these, so this allows us to get what x values at which these two they meet, right? So if we do that, then you're gonna get what is h of x. Remember, h of x is the new function. This one, the tangent, no, not the tangent, the line that is parallel to AE. So this is gonna be 0.25x minus 8.25 mass equals to x plus 4 x minus 6. Okay. Yeah, so remember, we can just simplify quickly the right hand side, which is x squared, as we've done, minus 2x minus 24, right? So we can just combine the like terms, right? You can just combine like terms and then essentially move everything to the right. So if we do that, then we're gonna have on the left hand side 0 equals to 0 is gonna equals to x squared, right? So minus 2x. And then if this guy goes to the other side, it's going to be minus 2.25x, right? Because it's going to take negative. And then 8.25, when it goes to the other side, it's going to become positive. Then that means the answer that you're going to have, I think, is going to become minus 15.75. Let's just check that. Okay, so minus 24 plus 8.25. Okay, minus, yes, that's correct. So then what you need to do now is you need to solve this equation. X squared minus 2.25x minus 15.75. So yeah, you can just use your quadratic formula to solve this, right? You can just use your quadratic formula to solve this. X equals to minus b plus minus b squared minus 4ac over 2a. So yeah, you can just substitute this into the quadratic formula. So yeah, you're gonna get 2x values. You're gonna get 2x values. So if we do this, you're gonna get so you're gonna get minus 25. Okay, yeah, I think just maybe to save time, because I think the key principle was just that you needed to understand that the parallel line and the line AE, like, they have to have the same gradient from the properties of parallel lines, and then also to recognize that where the two functions, they meet each other, then you have to equate the functions so that you can get the x values. And then once you get the x values from this, you're going to get two x values. The other one is going to be minus 3, which you already given. And the other one is going to be what we don't know, right? Let's say xp. So you're going to take this guy, and then you substitute what? You're going to substitute x of p into what? Into either h of x or f of x, right? And that's going to give you your corresponding y value. Therefore, then x of, let's just say x of r, not xp, x of r and y of r, right? So that's going to be the answer that you're looking for, the coordinates of r, where y of r is what? Is f of xr, or like, h of xr. Okay, yeah, that's essentially how you get the coordinates of r there. The principle is that one. Yeah, and I think this brings the end to our lesson. Hope, like, yeah, this makes sense to you, and yeah, you're able to apply these concepts that you've learned over the past 2 lessons into your exam questions. And yeah, please let me know if you have any questions, and yeah, please share your comments about how you're finding these videos, and let me know what you want to see next, because yeah, I want to do the content that yeah, that is tailor-made for your problems, right? So I don't want to make the content that I think it solves your problem. I need to make the content that it really helps you to solve your problems. Okay, yeah, thanks for watching this video, and please don't forget to like and subscribe so that you don't miss out on the next videos that I'm going to be releasing. And yeah, I'm looking forward to see you next time. Okay, cheers.